All right, we're gonna pick up where we left off in the last one by talking about using Python, the Python interpreter, as sort of a substitute for the Shadowrun game, so that we have more control over the values. So we're gonna start to get into some of that stuff right now. We have some new wallpaper here. The question being, how do you weigh a 21-foot Python? Apparently, that's how you do it. So, quickly jump in here. Go to Wikipedia, Python programming language. In case we have any questions or we want to prove a point or something like that, we can just pull this right up. A lot of it's going to be right here in this page. So we'll go back down here. Going to open the Python interpreter back up. Let's see. Do I want to use the GUI? That's what we used last time. So for continuity purposes, make new shortcut. Put this down here. Open it up. A bit of that, and I got rid of the notepad from the previous video, but it's all right. The same. Want to say we had a variable to some effect with this name set to some value. I think it was 35 or something like that. So obviously, we know how to find values in the karma value and whatnot in Shadowrun. We know how to find that with Cheat Engine. We've done it a million times. Really simple stuff. We've also beaten the concept of variables to death to the point where we've just beaten it to death beyond any reasonable doubt. So we should be comfortable with the basic concept by now of what we're doing right here and what does this mean. We know what it means just as an abstract concept, and so we know the process that the computer goes through, and we know that what we're seeing here as a statement in a programming language. What is this really doing? Well, there's some intermediate step here that is handled behind the scenes. It's, for our purposes, we're just going to say it's a black box, and there's some part of a computer in here that deals with memory. Yeah, we'll just say we will call it the memory manager. So again, there's just sort of this middleware, if you will, that builds up an abstraction layer with computers and allows us to be able to refer to variables as name and never have to worry about their actual memory, or their actual location rather, in memory, whether that's a relative address or an absolute address, or whatever sort of fancy qualifier you want to apply. It's an address somewhere, and we don't ever have to know what that value, what that location really is. So let's type in this to Python here. And again, in previous videos, we know that Python accepts that sort of. Can we use tab completion? We can, but we know what we're doing here as far as Python. Python's saying you're taking a constant value, you're making a variable named karma underscore points underscore available. You're stuffing the constant or the value of 35 into that variable, and now whenever you refer to that variable, it's just going to go back to the memory location of the middleware. It'll get that memory location, it'll dig out the value, and it'll return that value to you. We could not just give Python not just variables, but we could just give it two constant values. It'll evaluate that expression and say, yep, that's 2. 1 plus 1 times 2, it's going to be 3. So using that, we can not just ask Python what the value of a variable is. We can just say, we can apply expressions, statements, if you will. Say, what is karma points available plus 1? Now, we've gone over this, so I'm not going to harp on this, but it goes in, finds the value of whatever the value of that variable is, it adds 1, and then it returns that value to us. So what we're going to do is we're going to use Cheat Engine to find a value that we're going to set in that Python interpreter. So how are we going to do that? We're going to do it the same way that we would if we were to use Cheat Engine to find a value in Shadowrun the game. So in Shadowrun in the process. So we open up Cheat Engine. We're gonna have to link it to Python. There's 2 instances here, so they're we don't know what the actual hex or what the identifier for the process is. We just know the name. Um, so there may be a little trial and error associated with it, but we'll figure it out. For our purposes, we're gonna just go with the first one, and if we absolutely can't find the value, then we'll try messing around with the second one. So how are we gonna do this? We don't know the name of the variable. We don't care. The only thing we're looking for right now is value. Um, Again, this concept that should be very familiar as far as using cheat engine. So we got 5 minutes all over that. So we could, what's the value of this variable? We could search for 35. Let's do that. Let's see what results we get. 720. See if we can do that. Set that variable to 36. See if we can filter down 36. We can. Let's make sure. Let's shrink this down a little bit so we can still see it when we're typing in the interpreter here. Let's say karma points. Certainly not karma pointers. Karma points available. I'm gonna set it to 37. We're just changing the value. Now, if our logic is correct and we have found the right address, as soon as we hit enter and Python processes this statement, it should immediately change down here in Cheat Engine. So let's see what happens. Go back up here. We hit enter. Value changes to 37. That's pretty amazing stuff. If we'll mess around with this value a little bit more. If it's not absolutely clear to you what's going on, we could make. We're proving the point that it doesn't matter. We don't want to, as far in the context of using Cheat Engine, we don't ever care what the name of the variable in the source code is. The only thing that we're doing is we are concerned with the value over here on the right side, or what the value of the variable is. If we're not talking about expression, we're just talking about values. The only thing we're looking for is the value. See if we can maybe be a little more concrete about that. Set this to something else. I don't know. Let's make it 90. See if this value changes. Nope. So this illustrates a point about finding values in general, which is when you find a value, it's possible that the process you're attached to may allocate and reallocate memory, in which the whole reason we're talking about this is so we can find out how to deal with the memory changing. So this is an address relative to this process. We just changed this to up to 90 here. The value did not change down here. So what just happened? What just happened is that the Python interpreter deallocated the memory that was associated with this variable, or it changed, more specifically, it changed the location of memory that this variable was associated with. So now when we go in and we start playing around with this value via Cheat Engine, it's not going to be reflected up here, and when we change it, or it's not going to be reflected in Python, and when we change it in Python, it's not going to be reflected in Cheat Engine, because Cheat Engine is looking at this address, and Python, meanwhile, has some other address that it's associating with this variable. Now, why did that happen? Can we see if we can maybe go over that a little bit? The reason that happened is because there's all sorts of internal rules involved with the middleware of memory management, and it's different for every application. And Python happens to have a whole lot of dynamic memory management that goes on under the hood. It's an incredibly complex topic. There's people who write programming code and things like that, and their whole mission in life, and they get paid huge amounts of money, is to figure out efficient ways to deal with memory management and the allocation and deallocation, or reallocation, as the case may be, of memory behind the scenes in a transparent way, so that end users, i.e. programmers or application developers, in any event, don't have to deal with this kind of stuff. So when you're using Cheat Engine and you're finding values or you're looking for values and whatnot, you're sort of, as we've talked about, you're sort of reversing the general process of what you do in a programming language, which is you make a variable, you assign a value to it, and that's all you do in a programming language. The rest is completely under the hood. And then when you start using Cheat Engine, what you're saying is, I want to reverse this process. Instead of doing it in this direction, I want to start looking for this, and I want to go back to this middleware step, and I want to find the memory location that is associated with that variable. And that's what we're illustrating right here. So let's just to make sure it wasn't a total fluke, let's make up some other. We're going to use the same variable name, because it doesn't matter what we name the variable. It's just under the hood, this middleware, this memory manager is just associating some random address, some random memory location with this variable in a way that is hiding from us on purpose in Python. So let's set this to some value that we can easily find with Cheat Engine. We're still attached to the same process. 1, 2, 3, 4, 5. Hit enter. We get 3 values. Let's change this in here. We will set it to something else. 5, 4, 3, 2, 1. We have 3 addresses in memory or in Cheat Engine over here. And if we hit enter here, we should see one of them change. Do we? We do. This one is now 5, 4, 3, 2, 1. Let's ask the Python interpreter, what do you think the value of that variable is? That's great. Now this one has changed back to 419. Again, what has probably happened is if we were a little faster, we probably could have changed the value and then seen it reflect up here. If we reevaluated this, or if we asked Python to check the value, you know, again, if we were faster down here and then we changed the value in Cheat Engine and we came back here and we asked Python to recheck the value of that memory location associated with the variable, it would return whatever we changed the value to down here. But again, the reason that it's changing, the reason that this value is changing and it's no longer reflected in Cheat Engine is because we're using a very specific address in Cheat Engine, and behind the scenes here, Python's doing all sorts of memory management and juggling stuff around. It's changing the locations that variables are associated with in a transparent way, and it's that's fine, that's great. We want it to do that. It increases programmer productivity. But a side effect of that is, and what we're trying to demonstrate here with Cheat Engine is that when you find a value, when we're doing this little trick here of attaching Cheat Engine to a Python interpreter, you have to be aware of some of what's going on here in the middleware. And for our purposes, what we're going to say is that the memory manager of Python is free to change the locations that variables are associated with on the fly in a rapid fashion, and it does. And so let's see if we can make a variable and give it a value, just like we did before. And then we'll use let's get rid of this. We'll use Python. Or I'm sorry, we'll use Cheat Engine to find that value. As soon as we think we found that value, we're going to quickly, or try and be quick about it, we're going to change it down here in Cheat Engine, go back, ask Python to reevaluate it, and you'll see that we will not have reassigned a value to the variable, but we should see the value that we assigned to the memory location down here in Cheat Engine reflected up here in Python. Let's see if we can make that happen. 1, 2, 3, 4, 5. We'll change this somewhat quickly to 5, 4, 3, 2, 1. That's what the value is. Come on, my mouse is messing up. Change this to 5. All right, we saw the value change there. Let's go back, ask Python. Too slow maybe. See if we can do that again. See if we can make this happen. All right, hit enter a couple times. Nope, we want it to be more random than that. So we're gonna set this to 5, 4, 3, 2, 1. First scan. We get one value, immediately going to come up here, change this to 1, come back down here, say what's X, still not working. Well, there might be something going on here in the middleware. Again, it might be juggling the addresses around in a weird way. So just got to ask it a couple more times. Let's change it to 5. See this value changing over here. All right, you know what? What do we got? Got about a minute. Let's give this one more shot. Let's think about this. Let's make a completely new variable. New variable. We see that value change here. Let's just try, I don't know. Let's see what we can do. Now we're just starting to poke random values into it. Let's see what we get. 90. Does this value change? Does not. Alright. Well, again, there's kind of a whole mess of middleware and memory management that Python uses, and it's probably what's going on here. We'll come back in the next video, see if we can mess around with this a little bit.